Hello students of class 10. Today I am going to start complex number. Uh, complex number. Complex number. And this is chapter complex number. Chapter 2. Chapter 2. This is chapter 2. Now, student class 10, this is advanced math. Advanced mathematics. Class 10. Class 10. So, exercise 2.1. Here we have to identify the imaginary numbers from the following. See, this is an imaginary number. 1 2 root minus 9. This is equal to, this is an imaginary number, root 9i, and which is equal to 3i. This is an imaginary number. Similarly, CB, this is also an imaginary number. This is also an imaginary number. Minus 7 into 5 minus 35, that is equal to root 35i. This is an imaginary number. But C, here C, this is root minus 3 into root minus 4, 12. So this is not an imaginary number. This is not an imaginary number. So again D, root to root 16, D root to root 16. This is not an imaginary number. Again I to the power of 12, that is I square to the power of 6 minus 1 to the power of 6 equal to 1. It is not an imaginary number. Not an imaginary number. It's not an imaginary number. Again, h minus I cube minus I to the power of 4. So this will be equal to minus I cube, and this will be I square, I4. So this will be minus I square into I, and this will be I square into the whole square. So minus I into minus 1 the whole square. So minus I. This is an imaginary. This is an imaginary number. Now I am going to question number 2. This is simplified. Question number 2. This is simplified. Simplified. First, I to the power of 35 plus 1 by I to the power of 31. So here I to the power of 34 into I to the power 35 I can write as I to the power 34 into I, 1 by I to the power of 30 into I. So this is I square to the whole power 17, 2 7 the 14, and 2 and 3 into I plus 1 by I square to the power of 15 into I. So this will be minus 117 into I, minus 1 to the power of 15 into I. So odd number minus I, and here also odd number minus I. So this will be minus I minus 1 by I. we have to rationalize this. Minus I into I into I. So this will be minus I by I square. I square is minus 1 minus I plus I, and so this becomes 0. This is the answer. Similarly, question number this 4 I to the power of 38 plus I to the power of 18. Again, I square 2 1 is 2, 2 9 is 18 plus I square 2 9 is 18. So this will be minus 1 to the power of 19 minus 1 to the power of 9. So odd minus 1 odd minus 1, this will be equal to minus 2. This is your answer. The rest I think so you can do it yourself. This I think you can do it yourself. Now I am going to question number 3. Question number 3 is this is express each of the following numbers in a plus id form. First, 2 minus root minus 5, so this will be 2 minus root 5i, so this will be 2 plus minus root 5 into I, a plus id form. Similarly, root minus 3 minus root 3, so this will be root 3i minus root 3, so this will be minus root 3 plus root 3i. This is the answer. These are the answers. So now question number 7, minus 1 into root minus 1 this whole power 4n plus 3. Now here you see this is minus 1 means I square, and this is into I to the whole power 4n plus 3. So this becomes I to the power of 3 I to the power of 3 to the whole power 4n plus 3. So this will be I to the power of 3 4 that 12n plus 3 is 9. So this will be I to the power of 12n into I to the power of 9. So this becomes I to the power of 12 to the whole power n into I to the power of 8 into I. So this will be I to the power of 2 to the whole power 6 to the whole power n into this will be I to the power of 2 to the whole power 4 into I. So this will be minus 1 to the power of 6 to the whole power n into minus 1 to the power of 4 into I. So even, so 1 to the power of n is 1, and here this is 1, so this will be I. So your answer becomes 0 plus I. This is your answer. Let me check the answer. This is exercise 2.1. Exercise 2.1. Exercise 2.1. Question number 3, 4. Question number 3, 7. Question 3, 7, 3. This is 0 plus I into 1 or 0 plus I. I can write like this also. So this is the answer. Now I am going to question number 4. Question number 4. This is Question number 4. Evaluate the following. Evaluate the following. So A, I to the power of 19 plus 1 by I to the power of 25 to the whole power 3. So this will be I to the power of 18 into I plus again 1 by I to the power of 24 into 1 by I power 3. So this will be I square to the power of 9 into I plus 1 by I square I can write like this. 1 by I square to the whole power 12 into 1 by I the whole cube. So this will be minus 1 to the power of 9 into I plus this is minus 1 power 12 into 1 by I. This is I. So whole cube. Again this is minus, so minus I. Again this is plus 1, this is into plus 1, so 1 by I the whole cube. Now again I am going to do, that is I into I whole cube. So minus I, this becomes plus I by I square the whole cube. So this is minus I minus 1 minus I. So this is whole cube. This is minus 2I the whole cube. So this is minus 8I cube. So this is minus 8I square into I, and this will be minus 8I. This is your answer. Let me check the answer. That is question number 4 first. 4 first, see, this is 8I. Now again I am going to solve another question. The question is D1 plus 1 by I plus 1 by I square plus 1 by I cube in I cube plus 1 by I4. So this I can write as 1 by I, 1 by minus 1, 1 by I square into I square into I plus 1 by I square the whole square. So this will be 1 plus 1 by I minus 1, and this is minus 1 by I, and this is I square minus 1, the minus 1 also 1 plus 1. So here this and this cancels out, this and this cancels out, 1 is the answer. So here see D, this is equal to 1. Now I am going to question number 5. Question number 5. Find the smallest positive integer. Find the smallest positive integer and for which the equality 1 plus I to the power of 2n is equal to 1 minus I to the power of 2n is 2n is satisfied. So here 1 plus I solution to the power of 2n is equal to 1 minus I to the power of 2n. We can write this as 1 plus I square to the whole power n is equal to equal to 1 minus I square to the whole power n. Now formula 1 plus 2I plus I square to the whole power n, 1 minus 2I plus I square to the whole power n. So 1 plus 2I minus 1 to the whole power n, 1 minus 2I minus 1 to the whole power n. So 2I to the whole power n is equal to minus 2I to the whole power n. Now to solve this I have to apply one technique. The technique is minus I can be written as 1 by I, because you see 1 by I, rationalize it, I by I square, this is equal to minus I. So minus I can write like this. So 2I to the power of n is equal to 2 by I to the whole power n. So this becomes I to the power of n is equal to 1 by I to the power of n. So I to the power of n into I to the power of n is equal to 1. So I to the power of 2n is equal to 1. So I to the power of 2n, this one is possible, this whole square. So from this I to the power of 2n, this is n, is equal to I to the power of 4. So 2n is equal to 4. So n is equal to 2. This is your answer. Now I am going to the second question. Second question 5b. This is for positive integer, and so that 1 minus I to the power of n, 1 minus 1 by I to the power of n is equal to 2n. So to prove it, left hand side 1 minus I to the power of n, 1 minus I to the power of n. This I can write as 1 minus I into 1 minus I to the whole power n. This I can write like this. So 1 minus I, and this is minus 1 by I, this is means plus I, 1 plus I to the whole power n. So this becomes a plus b a minus 1 square minus I square n. So this is equal to 1 minus plus 1, because I square is minus 1, I square is equal to minus 1. So to the whole power n, and this is equal to 2 to the power of n, right hand side. Now I am going to another question. This is question number 6. Find z1 plus z2, z1 minus z2, z1 into z2 when z1 and z2 are given. As I am going to do only one question for you, the rest you can do it yourself. z1 is equal to 3 minus 4i and z2 is equal to minus 2 plus I. So z1 plus z2, that is equal to 3 minus 4i plus minus 2 plus I. So this becomes 1 minus 3i. So z1 plus z2. So this is your answer. Similarly, z1 minus z2, that is equal to 3 minus 4i minus bracket minus 2 plus I. So this will be 3 minus 4i plus 2 minus I. So this will be 5 minus 5i. This is your answer. Now again z1 into z2, 3 minus 4i into minus 2 plus I. This will be equal to minus 6 plus 3i plus 8i plus 11i, and this is plus 4. So this will be minus 2 plus 11i. So this is your answer. Let me check the answer. Question number 5. Let me check the answer. Question number 5. 2.1. 6. No, this is question number 6. Sorry, 6a. 6a. See, first is 1 minus 3i. So 1 minus 3i. Second is 5 minus 5i. 5 minus 5i. And the third is minus 2 plus 11i. Minus 2 plus 11i. So your answer is correct. So now the rest of this question you can do it yourself. I am going to another question. That is question number 8. Question number 8. That is, if x is equal to 3 plus 4i and y is equal to 3 minus 4i, then find the following. Find the following. Find the following. So here first x square plus xy plus y square. So we have to just put the value. There is no other way. 3 plus 4i the whole square plus 3 plus 4i into 3 minus 4i plus 3 minus 4i the whole square. Just you have to evaluate. There is no other way. A plus b the whole square, 3 square minus 2 into 3 into 4i plus 4i the whole square. This is a plus b into a minus b, a square minus 4i the whole square. And here this is a minus b the whole square, 3 square minus 2, this is minus 2 into 3 into 4i plus 4i the whole square. So here you see that, see one thing, that is this and this cancels out, and again this is plus, this must be plus, this is because it is a plus b the whole square. So this and this cancels out. The remaining that is left, that is 9 plus 9 plus 9, and at the last is 16i square. So 9 3 are 27, I square minus 16. So this equal to 11. This is your answer. Let me check the answer. See question number 8. First this is 11. Now the rest you can do it yourself. It is only you have to put the value of x, xy and x and y. Just you have to put the value. The rest you can do it yourself. Now question number 9. Question number 9. This is question number 9. If x equal to 1 minus I, then so that x square minus 2x plus 2 equal to 0. So how to solve it? You can place the value of x and you can solve it, or there is also a way, that is x minus 2x plus 1 equal to 0. This becomes x minus 1 the whole square plus 1 equal to 0. So here the value of x is 1 minus I minus 1 the whole square plus 1 equal to 0. So that let me do this sum again. Let me do this sum again, because it was so that we have to prove it. So that x square minus 2x plus 2 equal to 0. So I am going to start from the left hand side, that is x square minus 2x plus 2. This I can write as x square minus 2x plus 1 plus 1. So this becomes x minus 1 the whole square plus 1. Now I am going to put the value of x, that is 1 minus I minus 1 the whole square plus 1. So here it becomes minus I the whole square plus 1. So this is equal to I square plus 1. So this is minus 1 plus 1, and so this is 0 equal to right hand side. Now question number 10, this is the last question of this exercise. Question number 10, 10, that is you have to factorize. We have to factorize. See how to factorize. First, x square plus y square. I can write this as x square minus iy the whole square, because I square is minus 1 and minus into minus plus. So this becomes x plus iy into x minus iy. This is your answer. Now second is, this is a square minus 1 minus 2ai. So I can write this as a square minus 2ai. Instead of minus 1 I can write as I square. So this will be a minus I the whole square. So this is the answer. Or you can write this as instead of since we have to factorize, so you can write this as a minus I into a minus I. This is your answer. Now the third, it is 16 root 2 minus 7. So here you see 16 root 2. I can do one thing, 16, that is 2 into 2 8 is 16. 2 8 is 16. I have written, this is not 16, it is I not 16, it is third, it is not 16, it is I 6 root 2 minus 7. I can write like this, minus 7 plus I 6 root 2, so this will be minus 7 plus 2 into 3 into I in root 2. So I can write like this. This is 3i square. This is a rough checking. 3i square, that is 9i square. That means minus 9 and plus 2. This comes to minus 7. So I can write like this. Instead of 7, I can write 3i the whole square. 3i the whole square plus root 2 the whole square plus 2 into a, that is 3i into root 2. I can write like this. So this becomes 3i plus root 2 the whole square. I can write this as root 2 plus 3i the whole square. So root 2 plus 3i into root 2 plus 3i. This is your answer. Let me check the answer. You see, it is root 2 plus 3i into, oh, here there is, okay, it's correct. Root 2 plus 3i into root 2 plus 3i. So this is your answer.